Our next speaker is Dr. Walter Senna, who's a 2002-2003 IMH Marshall Fellow under the supervision of Dr. Todd Woodward.
Okay, so I'll talk about what I've been doing these years, the development of neurocognitive assessments in all these 5 domains designed for low-frequency eye trackers. There's something wrong with the images here. I hope the rest is working. So this is Jack's chart. It's kind of well known regarding dementia, and this is just an example. It's not based on real data. It's just first to understand this concept that here is a CSF collection for detecting biomarkers, a PET scan, in this case, amyloid PET scan. And both of them kind of maybe come to, before other biomarkers like blood-based biomarkers, neurocognition assessments, and finally daily function. So the main idea here is that these more invasive biomarkers show before, and that's the problem. The solution to that, this is a real-world presentation I did recently. It's these neurocognitive assessment based on eye tracker, which understands better calling gaze tracker, because people understand it better. This is how it works. We know where people are looking at while they're doing this test, and this is what is behind. So these are fixation, saccades. You can see on the bottom instant measures of, we call attention, but I think it's arbitrary to name any cognitive domains. That's not top. So here you can see that longer saccades show up differently there at the bottom analysis. There's a lot we can get from gaze trackers, and a lot of information. This is a memory test. We would usually just talk about accuracy, but here we have much more information from it. So what's the relevance of all this? The idea is getting blood-based biomarkers, which are less invasive. And there are many different ones. For Alzheimer's, we've been talking a lot about GFAP, neurofilaments, A-beta 42-44 ratio, right? Phosphorylated tau. Anyway, we have that and more for all the diseases as well. And a bunch of, we're talking about 30 cognitive tests at least. And each of them has like 10 outcomes. Based on that, we will evaluate the risk of indeed developing certain neurocognitive disorder as Alzheimer's, but not only Alzheimer's, subtypes of Alzheimer. Instead of calling Alzheimer or frontotemporal or whatever, I would rather call them amyloid beta accumulation, phosphorylated tau accumulation. And not only that, but amyloid beta accumulation here in the prefrontal cortex, amyloid beta accumulation here in the hippocampus, whatever. These are unbiased. So we could maybe get a medium risk score saying that, yeah, you do have, unfortunately, to go through these invasive tests. Or a high score, and you should actually immediately start treatment. And that would be, for instance, donanemab or lecanemab. Lecanemab has been withdrawn just recently. Was it lecanemab or aducanumab? So lecanemab is still there, and aducanumab is just coming, right? And Lilly had good results. All right, so this is it. And why is it relevant? If we delay Alzheimer's disease by 1 year, we could reduce future prevalence by 11% and cut annual care costs just in the US by 219 billion. That's published in this forum. So if you want to try it, go to ubc.neurocognition.ai. It's working neatly. It takes only 5 minutes. And you get the results at the end, just raw results by now. Of course, we need to collect data to normalize. But that's it. Thank you.